Hey everyone, Linus here. Today we're diving into the world of Ethernet, the backbone of most local area networks, or LANs. You know, those networks connecting your computers, printers and gaming consoles at home or in the office. Ethernet is like the plumbing of your network, carrying data packets between devices. Imagine data as water flowing through pipes. Those pipes are your Ethernet cables and the water is your precious data. Ethernet is a wired networking technology, meaning it uses physical cables to transmit data. These cables plug into your devices and connect them to a network, allowing them to talk to each other and share resources. Without Ethernet, your devices wouldn't be able to share those funny cat videos or battle it out in the latest online games. So let's unravel the magic behind this essential technology. Ever wondered how your computer sends a file to your printer through the network? It's all about data encapsulation. Think of it like putting a letter inside an envelope before sending it. When you hit print, your computer breaks down the file into small data packets. Each packet is then wrapped in an envelope containing important information like source and destination addresses. This process is called encapsulation. These encapsulated packets are then ready to travel through the Ethernet network. They journey from your computer through the cables to a device called a switch, and finally to the printer. It's like a well-coordinated delivery service, ensuring your data reaches its destination safely and efficiently. Now, let's meet the traffic police of our network, the switches. Switches are like traffic directors in a busy city, ensuring smooth data flow within your network. They receive data packets from different devices and forward them to their intended destinations. But what happens when multiple devices want to send data simultaneously? That's where collision detection comes in. Imagine a four-way intersection with no traffic lights. Chaos would ensue. Similarly, data collisions can occur on the network, causing data loss and slowing things down. Ethernet uses a clever mechanism called CSMA-CD, or Carrier Sense Multiple Access Collision detection. To prevent this, it's like each device politely checking for traffic before sending data. If the coast is clear, they transmit their packets. If a collision is detected, they back off and try again later. This ensures that data flows smoothly and efficiently on your network, even during peak hours. Have you ever wondered how devices on a network identify each other? Just like your home address tells the mailman where to deliver your letters, each device on an Ethernet network has a unique identifier called a MAC address, or Media Access Control Address. This address is a 12-digit hexadecimal number assigned to the network interface card, or NIC, of your device. It's like a fingerprint, ensuring that each device on the network can be uniquely identified. When a device wants to send data, it includes its own MAC address as the source and the destination device's MAC address in the packet header. This way, the switches know exactly where to send the data. Think of it like addressing a letter. You write your address as the sender and your friend's address as the recipient. MAC addresses work similarly, ensuring that data is delivered to the correct device on the network. Section 5, Error Checking, Ensuring Data Integrity. Imagine receiving a letter with missing words or jumbled sentences. Frustrating, right? Similarly, data transmission on a network can sometimes encounter errors, leading to data corruption. To prevent this, Ethernet uses a technique called error checking. Before sending data packets, a special code called a CRC, or cyclic redundancy check, is calculated based on the data's content. This code is like a checksum, verifying the integrity of the data. When the receiving device receives the packet, it performs the same CRC calculation. If the calculated CRC matches the one received, it means the data arrived intact. If there's a mismatch, it indicates data corruption and the packet is discarded. The sending device is then requested to retransmit the corrupted packet. This ensures that you receive accurate and complete data every time. Section 6, Ethernet speed from megabits to gigabits. Remember the days of the dial-up internet, waiting ages for a web page to load? Thankfully, Ethernet has come a long way, offering blazing fast speeds for data transmission. Early Ethernet versions offered speeds of 10 megabits per second. Today, Gigabit Ethernet, offering speeds of 1000 megabits per second, is common in homes and offices. There's even faster 10 Gigabit Ethernet and beyond for demanding enterprise networks. This significant speed increase translates to faster file transfers, smoother streaming, and lag-free gaming experiences. Whether downloading large files, streaming 4K videos, or participating in intense online gaming battles, Ethernet speed ensures a seamless and enjoyable experience. Section 7. Security first, protecting your data on Ethernet. In today's digital age, security is paramount, and Ethernet offers robust features to protect your data from unauthorized access. Unlike Wi-Fi, which transmits data wirelessly, making it susceptible to eavesdropping, Ethernet uses physical cables, making it much more secure. It's like sending a confidential letter through a sealed envelope instead of shouting its contents in a crowded room. Additionally, Ethernet networks allow for network segmentation, isolating different parts of the network to enhance security. For example, you can separate your personal devices from work devices on your home network, adding an extra layer of protection. Moreover, using strong passwords for your network devices, like routers and switches, further strengthens security, preventing unauthorized access to your network and data. In Section 8, growing with ease. Ethernet's scalability. One of the most significant advantages of Ethernet is its scalability. Whether you're a small home office or a large corporation, Ethernet can grow with your needs. Expanding your Ethernet network is as simple as adding more cables, switches, and devices. You can easily connect multiple devices and even create separate subnetworks or VLANs, virtual local area networks, to manage traffic efficiently. This scalability makes Ethernet an ideal choice for businesses and organizations of all sizes, allowing them to adapt their networks as they grow without significant investments in new infrastructure.
Section 9, Conclusion. Ethernet, the reliable backbone. So there you have it, folks. Ethernet is the unsung hero of the networking world, quietly and reliably connecting our devices and enabling us to share, work, and play in the digital realm. Its reliability, speed, security, and scalability make it the preferred choice for ELANs worldwide. From homes and offices to massive data centers, Ethernet continues to be the backbone of our connected world. So next time you're enjoying a lag-free gaming session or seamlessly streaming your favorite show, remember to thank Ethernet, the silent champion.